So the next thing we're going to talk about is compound interest in the equation we have for it. And compound interest is interest earned or paid on both the initial investment and previously earned interest. Okay? Basically what it means is you earn a little bit of interest and then you start earning interest on that interest because that's added to your amount. It's basically exactly how any bank account you've ever had works. It compounds the interest. And what compound interest is an application of exponential growth. It's just a special case of exponential growth. So here's our equation for compound interest. This might be a little confusing because A is the current amount and P is the principal amount. If you want to, if it makes it easier, just cross out the A and put a Y, and then put an A in for the P, so it's exactly like our formula was for exponential growth. That will make it A is your initial amount. Okay? This is a little confusing the way they did it, so I don't really like that. So we're going to say Y is the current amount, and A is the initial amount. However, the way you will see this most of the times is with the P in there instead of the A. So if you want to cross out the Y, the A and the P and switch them to Y and A, go ahead. But I'm going to use this the way it's already written because we always talk about the principal is your initial amount. If you talk about the principal on a loan or principal in an investment, it's always the initial amount. That's what a principal is. So we've got our amount equals our principal times the quantity of 1 plus, and here's where it gets a little different for compound interest. Otherwise, it's exactly the same. It's our rate divided by n, and remember this rate is a decimal. N is the number of times the interest is compounded each year, which means if we'd say our interest is compounded quarterly, quarterly would be compounded 4 times, so you'd plug in 4 for n. If interest is compounded daily, well, each year there's 365 days, so interest would be compounded 365 times, so we'd plug in 365 for n. Monthly would be 12. Yearly it would just be 1. So there's semi-annually, you could have it compounded twice. A lot of different ways it can be compounded. That's what your n value is though. How many times is compounded in 1 year? And then t is the same thing, it's time in years. Make sure you always know time is going to be in years when you're dealing with compound interest. So you can see this is similar to the formula we had for exponential growth. It's just we add this divided by n and then multiply our t by the n. So in our example, we've got Maria's and parents invested $14,000 at 6% per year compounded monthly. How much money will there be in the account after 10 years? Well, we have our equation. Our amount equals the principal times the quantity of 1 plus our rate divided by the number of times compounded in 1 year raised to the power of the number of times compounded times the number of years. So what I need to do, I need to find P, R, N, and T in order to find out this amount. So P, amount they initially invested, 14,000, so there's my principal. My rate, 6% per year, so there's my rate. But remember, we want this as a decimal. 6% as a decimal would be 0.06, divide 6 by 100. Number of times compounded, well, it says it's compounded monthly, so we need to think, how many months are there in a year? There's 12 months in a year, so the number of times compounded in a year is 12, and then they tell us we want to know after 10 years. Now all we have to do is plug in these numbers. The amount we have equals our principal, 14,000, times the quantity of 1 plus R, remember to write this as the decimal, 0.06 divided by n, 12, raised to the power of 12 times 10. And now I'm just going to simplify it. A equals 14,000 times the quantity of 1 plus 0.06 divided by 12 gives me 0.005 raised to the 12 times 10, which is 120. A equals 14,000 times the quantity of 1.005 raised to the 120. A equals 14,000 times 1.005 raised to the 120 gives you 1.8194. And remember, your calculator is going to give you a bunch of numbers after this, so do not just write 1.1894 in your calculator. Leave whatever you get in your calculator, and then just press times 14,000 so it keeps all those extra decimals. And when you do that, you get $25,471.55. Again, all we did was use the formula. Since it's a word problem, let's go ahead and write our sentence. There would be $25,471.55 in the account. And that's all there is to it. It's just applying a special form of exponential growth, which is compound interest. Just got to find the numbers to plug into the formula and then evaluate the formula.